All right, so now we're going to tackle these sideways parabolas. So x equal 4 minus y squared. So we know that that's an upside down parabola, so facing to the negative x-axis, shifted up 4. And then we know that x equals 0 is this y-axis. All right, so let's look at what that area is that's bounded. So that would be this area here. All right, so in order to draw the rectangles, if I draw them like I've been drawing dx rectangles like this, that is not going to be useful because it's going to have the same function on the top as it does on the bottom. So I'm not going to do that. So I'm going to get rid of that. Whoops. And I'm going to put that x-axis back in. So I'm going to consider drawing the rectangles sideways. So drawing the rectangles this way. So if I draw the rectangles this way, so now the big deal is that the thickness of the rectangle will be this way. So it's going to be a dy thickness, right there, right there. And when we're dealing with sideways, the positive x-axis is the top and the negative x-axis is the bottom. So just like we use the positive y-axis as the top and the negative y-axis as the bottom, same idea. All right, so right is top and left is the bottom. So setting up the area, I'm going to encourage you, as soon as you see that you're using dy integration, that you put that in first. So integral of, you're going to have top minus bottom in here, and thickness of the rectangle is dy. So the top of the rectangle touches the function 4 minus y squared, and the bottom touches x equals 0. So we could put it in there for effect, but we don't need to. It's just like before when we would have functions, integrals, when we did area bounded and we had the rectangle touching the top function and then the bottom was the x-axis. So now it's going to be touching the y-axis. All right, so now I need to find the limits of integration. So this is a big deal. Because this is dy integration, these must be y values. So here and here have to be y values. So where am I going to start building rectangles and where am I going to end building rectangles? So that's going to be when these two functions equal. So 4 minus y squared equals 0. 4 is y squared. So plus or minus 2, or you can see, are the limits of integration. So I start building rectangles down here at -2, and I end building rectangles up here at 2. So that is the reason I'm going to encourage you to put dy here first, so you can see what kind of limits of integration we need. All right, let's do another one. X equal y to the 2/3. So this is another one of those basic graphs I just want you to know. And then to get the graph x equal 4, so that's x equal 4, looks like this. All right, so to find the area bounded, this is the area bounded. So again, I don't want to do rectangles. I'll draw it off to the side here. I don't want to have rectangles this way, dx integration, because they would have touched the same function on the top and on the bottom. So that is not a good choice. So let's do sideways rectangles. So if I do sideways rectangles, remember this is always the top function and this is always the bottom. So I can see I'm always having the green function on the top and the blue on the bottom. So let's set up the integral. So I can see it's dy integration because the thickness of my rectangle is dy. And I'm going to have top minus bottom. So the top function is x equal 4. So that's the top function. The bottom function is the y to the 2/3, x equal y to the 2/3. Now I have to find the y values for the limits of integration. So where do these two functions intersect? Because this is where I want to start building rectangles and this is where I want to end building rectangles. So if I set 4 equal to y to the 2/3, that's like saying 4 to the 3/2. You know this half here means take the square root. So I'll get plus or minus 2 cubed, so I'll get plus or minus 8. So from -8 to 8. All right, so sometimes I am going to do this. I'm going to say what kind of integration to use. So if I say use dx integration, then I'm telling you how you have to draw the rectangles. So let's try draw y equal x. And now let's draw x equal y squared. So you know x equal y squared is the sideways parabola. I'm going to emphasize the curve there so I can see the area bounded. So if I'm using dx integration, I'm making rectangles this way, right? Where the thickness of the rectangle is this way, dx. All right, so dx area. So top, so this is the top. The blue would be the top, and the black would be the bottom of the rectangle. So the top of the rectangle is touching the graph of x equal y squared, and the bottom is touching the graph y equal x. Ah, danger, danger, right? So I see x and y. Oh, this needs to be corrected, right? So this could be your initial step, and then you go back and you change this, and you say, okay, I can't have y's inside my x integration, so I need to take this x equal y squared, and I need to solve it. So I get plus or minus root x is equal to y. So you know positive root x is the one in the first quadrant, and negative root x is down in the fourth quadrant. So I'm going to erase this, take this out, and I'm going to be using square root of x. Square root of x, the positive square root of x minus x. Okay, so these have to be x limits of integration here. So I think we can use our logic here. We can see that they're going to start at building rectangles at x equals 0, and we're going to finish building them where root x and y equal x intersect, and that's going to be 1. All right, so let's do that same problem. And let's do dy integration. So it's going to change it. We'd get the same numerical answer, but let's just make sure we draw the rectangles correct and we get the right function in. All right, so now I'm going to be drawing rectangles this way, where this will be the top of the rectangle and this will be the bottom of the rectangle. All right, so dy integration, integral. So top of the rectangle is the line y equal x. Well, since I have y here, I'm going to use x equal y, subtract off the bottom, which is y squared. Top minus bottom. And then again, I'm going to be using y limits of integration. So I can see I'm going to start at y equals 0, and it's going to be y equal 1 where they intersect as well.